Welcome everyone. I'm Ahmed Mahmoud from DataMind AI, and today I'm here to reveal the real reason so many AI projects fail. The reason AI fails is not because of the algorithm, nor is it because of the models. It is not the lack of advanced AI capabilities. AI fails because of something far more fundamental and far more fixable. It is bad data. AI does not collapse because it is not smart. It collapses because the data underneath is incomplete, inconsistent, biased, or simply wrong. And you cannot build precision AI on imprecise data. Today, I will show you why bad data is dangerous, how it destroys AI in the real world, and what you can do to fix it at scale. Let us dive in. Let us look at a few numbers that should worry anyone investing in AI. First, 87% of data science projects never make it to production. Almost 9 out of 10 fail before delivering any value. That is not a minor issue. That is a systemic collapse. Second, Gardner estimates poor data quality costs organizations 15 million per year, not to build AI, just to deal with bad data, wasted resources, failed projects, compliance risks, lost opportunities. And third, AI now makes millions of high-stake decisions every day. Hiring, healthcare, loans, security, eligibility. So when data is wrong, the consequences are not just financial. They impact people's lives, livelihoods, and future at a machine scale. This is not theoretical. Let me show you what happens when it gets wrong. Let us start with Amazon, a company with world-class AI talent. In 2018, Reuters revealed that Amazon had built an AI recruiting system designed to automate CV screening, and it learned to discriminate against women. Why? Because the Amazon trained the model on 10 years of historical hiring data from a workforce that was overwhelmingly male. So the AI copied the pattern. It treated male as signal for success. The system began penalizing CV with terms like women's, downgrade applicants from all women's colleges, and quietly embedded gender bias into every recommendation. Amazon tried to remove gender clues, but the bias was already baked into the pattern the model had learned. In the end, they scrapped the entire project. The problem was not the algorithm, the problem was biased data, historical discrimination replicated at machine scale. And this example reveals the core issue behind failed AI system. Before we look at more failures, we need to define what good data actually is. Data quality is not vague. It has 6 measurable dimensions. Accuracy. Does the data reflect reality? Amazon's hiring data was accurate historically, but it encoded bias, and accuracy without suitability still breaks AI. Completeness. Are the essential fields filled in? Missing value force models to guess, and guess lead to misdiagnosis, wrong credit decision, and faulty prediction. Consistency. Is the data standardized across systems? If dates, names, or codes are not aligned, your AI will treat the same entity as multiple different records and fail. Timeliness. Is the data current enough for the decision you are making? Old behavior patterns produce wrong conclusion. Markets evolve, fraud evolve, your data must too evolve. Validity. Does the data follow business rules? Negative ages, impossible timestamps, or invalid categories quietly poison training and produce nonsensical output. Uniqueness. Is each entity represent once? Duplicate, distort distribution, skew inside. and mislead models. And here's the key points. You need all six. You cannot trade completeness for accuracy or consistency for timeliness. AI only works when every dimension holds. When even one fails, real people get hurt. Let me show you how. So how do you actually fix this? You need a systemic four-layer data quality framework. This is not optional. It is a foundation every AI system depends on. Layer number one, prevention. Stop bad data before it enters your pipeline. Use schema validation and data contracts, formal agreements on formats, ranges, required fields, and business rules. If the data does not meet the contract, it does not enter the system. Layer number two, which is detection. Some issues will still slip through, so you need automated checks at every stage. Outlier detection, distributed monitoring, completeness checks, and pattern validation. These runs continuously and catch issues the moment they appear. Layer number three, correction. When something breaks, don't just fix the records, fix the root cause. Cleans faulty data automatically, trace errors to their source, and repair the upstream system generating the problem. Layer number four is monitoring. Quality does not stay good by accident. Use dashboards, alerts, and drift detection to track changes in your data over time and ensure your models stay reliable. Most organizations skip all of these and go straight to building models. That is like constructing a skyscraper without checking the foundation. It may stand for a while, but it will collapse. Now, let me show you exactly what that collapse looks like. Before we continue, if you are finding this valuable, I would love your engagement. Subscribe to the DataMind AI channel for deep dive technical content on AI engineering and data quality. Comment below with your own data quality horror stories. Trust me, we have all got them. Connect with me on LinkedIn, where I share daily insight on AI and data engineering, and visit DataMind Mind AI with Ahmed.com for case studies and consulting services. Now, let me get back to why this matters so much. Let me show you the cascade effect that makes bad data so dangerous. It always starts small, maybe a 5% error rate. That sounds harmless until the model tries to learn from it. Bad data produces unreliable prediction. Your 5% data error quickly becomes a 15% prediction error as the model amplifies noise and mistakes. Those unreliable predictions lead to unsafe decisions. Qualified applicants rejected, diagnosis missed, fraud approval, the wrong people hired. And those unsafe decisions snowball into expensive failures, fines, lawsuits, reputational damage, and customer loss, and full system rebuild. Here's the cost, the core truth. You cannot build precision AI on imprecise data. AI does not magically create quality. It amplifies whatever you give it. If you feed it excellence, it scales excellence. If you feed it garbage, it scales garbage at machine speed and machine scale. So the question is not whether your data is perfect. The real question is whether you have the process to measure, monitor, and improve quality. Without that, you are building on sand. Let us talk now about the costs that never show up on the balance sheet, but quietly destroys organizations. First, bad decision. Leaders make strategic choices based on dashboards and reports. If the data is wrong, the decisions are fiction. You expand into the wrong markets, cut the wrong products, and steer the companies blind. Second, broken automation. One person with bad data makes one bad decision. An AI system makes a million bad decisions before anyone notices. Third, compliance and the regulatory risk. GDPR all require high quality data. Bad data means incorrect reporting, audits, fines, and legal exposure. Fourth, customer trust erosion. When AI denies legitimate claims, send irrelevant messages, or make unfair recommendations, customers leave and they don't come back. Brand damage from AI failure last years. Fifth, massive reward costs. Finding a data problem late means retraining models, reprocessing decisions, and rebuilding entire system. It is the most expensive kind of technical debt. Gartner estimates that 40% of AI initiatives fail because of data quality alone. No model complexity, no compute, simply data. Now let me show you how this unfolds into the real world. This next example is especially sobering because it involves patient safety. A major healthcare AI system was trained entirely on medical images from a single hospital network. On that equipment, in that environment, it performed extremely well. But when it was deployed nationally, it started failing badly. Why? Because imaging data is not consistent across hospitals. Different scanners, different calibrations, different protocols, different positioning technique, all of this changes how an image looks. The AI had not actually learned what cancer looks like. It learned what cancer looks like on one specific scanner in one specific hospital under one specific set of conditions. When it encounters images from other hospitals, it broke. False negative for cancer, missed pneumonia, incorrect fracture assessment, thousands of patients receiving potentially wrong diagnosis before the issue was detected. The root cause was not the algorithm, it was inconsistent data collection and a complete lack of validation that the model could generate beyond its training environment. And in healthcare, bad data does not just cost money, it costs lives. But this problem is not limited to hospitals. Financial service experience it just as severely as a hospital. A top 10 global bank deployed an AI credit risk model to speed up lending decisions. Instead, it triggers a compliance crisis. The model began falsely rejecting qualified applicants. And worse, the rejection pattern showed demographic biases that violated fair lending laws. Regulators discovered the root cause. The AI was using proxy variables, things like postcode, spending pattern, even mobile phone type, individually harmless, but highly correlated with protected characteristics. In the historical data, these variables did predict default risk, but only because that data reflected decades of discriminatory lending practice. The AI simply learned the bias and scaled it. The result? Over 10 million in regulatory fines, a complete model rebuilt, months of business disruption, long-term reputational damage. The real failure was not the algorithm again, it was assumption that historical data was neutral and fit for purpose without checking for fairness or bias. They trained on discrimination and the model reproduced it at machine scale, and it costs dearly. In 2019, Apple launched the Apple Card sleek design, seamless integration backed by Goldman Sachs. It looks like the future of consumer credit. Then the algorithm controversy hit. A well-known tech entrepreneur tweeted that he receives 20 times the credit limit of his wife, even though they filed joint taxes and she had the higher credit score. The story went viral. New York regulators opened an investigation. More customers reported the same pattern. Apple and Goldman Sachs insisted the model didn't use gender as an input, and that was likely true, but that was not the real issue. The algorithm was using proxy variables that strongly correlated with gender, and the historical training data almost certainly reflect past gender disparities in lending and financial behavior. The AI didn't need a gender field to discriminate. It just needed pattern that mapped to gender. The fell out. Regulatory scrutiny, mandatory model audit, a public relations storm, and serious question about whether the training data was ever suitable for fair lending in the first place. The core problem, they never validated their data for fairness across demographic groups. They assumed removing explicit gender field was enough. It wasn't. Again, IBM Watson for oncology was meant to transform cancer care. Hundreds of millions invested, top hospitals on board. The promise, AI-powered evidence-based treatment recommendations. But then internal documents from Memorial Sloan Kettering revealed something shocking. Watson was making unsafe and incorrect recommendations. One leaked example was terrifying. Watson suggested a treatment that could cause severe bleeding for a patient who was already experiencing severe bleeding, a recommendation that, if followed, could have been fatal. How did this happen? With world-class AI teams and access to vast medical literature, the data. Watson was not trained on real patient outcomes. It was trained largely on hypothetical, idealized cases created by a small group of doctors at one institution. These cases were medically plausible, but they reflected one hospital preferences, assumptions, and biases. They didn't represent the complexity, diversity, or uncertainty of real patients. So when Watson met real-world oncology cases, it produces recommendations based on theoretical medicine, not validated clinical evidence. Hospitals withdrew. IBM took major write-downs, eventually losing around $62 million. The root cause, not wrong data, but data that was not representative of reality. Technically accurate, but completely unsuitable for training clinical AI. And in medicine, that mismatch is not just expensive, it is dangerous. By now, you might be thinking different companies, different industries, different use cases. Is there really a common pattern? Yes, it is the same everywhere. Organizations systematically fail at 6 core data management practices. At the collection level, data is gathered without standards, without validation rules, without considering how it will be used for AI. It accumulates, but no one asks, is this accurate, representative, unbiased? Number two is validation. There are no automated checks at ingestion. Bad data flows straight into systems, and by the time anyone notices, it has contaminated months, sometimes years of downstream data. Governance. Ownership is not unclear. Who is responsible for data quality? Who fixes issues? Who defines what good enough means? Often nobody. Integration. Systems operate in silos. CRM data conflicts with billing data, which conflicts with marketing data. When you integrate for AI, those inconsistencies explode. Monitoring. No one tracks quality metrics, completeness, consistency, timeliness, drift. Issues grow quietly until they cause major failures. Lineage. Organization cannot trace data back to its source. Something goes wrong and no one knows where it comes from or how it fixes upstream. The result, AI becomes a mirror of the existing data chaos, amplified at machine speed. Every inconsistency, every gap, every historical bias, the AI learns it and scales it up. This is why 87% of AI projects fail, not because of weak models, but because of weak data management. Now let us talk about a problem that catches even the most mature organizations, data drift. Data drift happens when the world your model was trained on is no longer the world it is making prediction in. Your model learned, for example, from 2023 data, but it is operating on 2025 behavior. The most dramatic example was COVID-19. In March 2020, every consumer behavior model broke overnight. E-commerce forecasting, trained on world where people shopped in stores, suddenly irrelevant. Credit risk models, income, employment, and spending pattern flipped instantly. Fraud detection systems flooded with false positive because normal behavior no longer looked normal. Historical data that was reliable in February was obsolete by April. But here's the key. You don't need a pandemic for drift to happen. It happens constantly, just more quietly. Consumers change preferences, markets shift, regulations evolve, competitors create new patterns, technology adoption reshapes behavior. And if you are not monitoring drift, if you are not checking whether production data still matches the training data, your accurate models silently becomes dangerous. It keeps predicting with confidence based on patterns that no longer exist. This is why continuous monitoring and retraining are not optional. They are core requirements for any AI system in production. After all these failure stories, let us flip at the question, what does success look like? What is the anatomy of truly AI-ready data? It goes beyond the 6 quality dimensions. AI-ready data has 9 essential characteristics, and you need all of them. It must be accurate, aligned with ground truth, validated against reality, with known error bounds. It must be complete, required fields populated, no systemic gaps, nothing mysterious missing. It must be consistent, standardized, format, unified definitions, no conflicting versions of the same entity. It must be timely, updated at the right frequency for the decision you are making, not stale snapshots from years ago. It must be valid, conforming to business rules with logical integrity, and enforced constraints at the schema level. It must be governed with clear ownership, stewardship responsibilities, and accountability for quality. It must have lineage, fully traceability from source to models, with visibility into every transformation along the way. It must be bias checked, validated against demographic groups, audited for proxy variables, and tested for discriminatory pattern. And it must be monitored with continuous quality checks, drift detection, and alert when data starts to degrade. Notice something about this list. Most of it is not technical, it is organizational. It is process, ownership, and discipline. You can buy the best platform in the world, Fabric, Databricks, Snowflake, but without the organizational practices, to maintain quality, those platforms will not save you. Speaking of platform, let us talk about the technology that can help you. And the good news is this: modern data platforms now include capabilities for data quality that simply didn't exist 5 years ago. You don't have to build everything from scratch. Let us start with platform native tools. If you are using Microsoft Fabric, you get built-in data quality dashboards plus Microsoft Purview for governance, cataloging, classification, and lineage, all integrated into your data flows. If you are on Databricks, you get two powerful capabilities: Delta Lake, which provides native constraint enforcement. You define expectation at a table level, and Delta Lake simply won't allow violation. Unity Catalog, which brings centralized governance, access control, lineage, auditing, data discovery, and consistent security policies across all your workloads. Unity Catalog is essentially Databricks' unified governance layer for both data and AI assets. Database also includes monitoring features that track quality metrics, detect drift over time. Snowflake offers built-in quality functions in SQL plus tag-based governance to manage sensitive data and enforce access rules consistently. But platform native tools are only part of the picture. For deeper specialized quality frameworks, Great Expectations gives you Python-based validation with rich expectations you can run in any pipeline. Monte Carlo provides full data observability, detecting anomalies and alerting you to unexpected changes before they break downstream systems. Collibra and Informatica provide enterprise-scale governance, catalogs, lineage, policy enforcement, and stewardship workflow. The goal is not to choose one tool. The goal here is to build a stack that delivers three essentials. Number one is automation, quality checks that run continuously. Number two is observability, real visibility into what is happening into your data. Number three is governance, enforceable standards with clear accountability. So the question becomes, how do you actually implement these inside your organization? Now, let me give you a concrete roadmap that I feel is very useful. You need to take it step by step. Step number one is like, for example, assess your current state. Start with the quality audit of the data set that matters most. The ones powering your highest value AI models and business decisions. Measure completeness, accuracy, consistency, and timeliness. Most organizations are shocked by what they discover. Step number two, define business aligned quality rules. Don't just say we need good data. Define clear, measurable expectations. Emails must be valid. Transaction amounts must be positive. Dates must fall within logical ranges. Rules must map directly to business needs, not arbitrary technical preferences. Step number three, implement automation. Embed quality checks into every pipeline stage. Validate at injection, recheck after each transformation, test before loading into target systems. Think of data quality checks the same way software engineers think about unit tests: automatic, continuous, and non-negotiable. Step number four is establish governance, assign data stewards for key domain, create real accountability, define escalation path for issues and decision rights for resolving them. Governance is not bureaucracy. It is a clarity about who owns quality. Step number 5, build observability. Create real-time quality dashboards. Monitor daily by the data teams and execs as well. Track trends, set thresholds, trigger alerts when quality starts to degrade. Remember, what gets measured gets managed as well. Step number 6, continuous improvement. Feed model performance back into your quality process. When a model drifts or degrades, investigate the root cause. Is it quality? Is it drift? Is the world simply changing? Use this insight to update rules and strengthen pipeline. Critical point. Don't try to fix everything at once. Start with AI use cases that have the highest value or the highest risk and make those data flow uh, bulletproof. Then expand step by step. Now with a practical example, let me share 5 production grade practices that separate organizations with reliable AI from organizations whose AI fails in the real world. Practice 1, implement data contracts. A data contract is a formal version agreement between data producers and data consumers. Marketing commits to delivering specific fields, formats, and quality guarantees. Data science commits to expected types and volumes. When a contract is violated, the system fails fast and alerts immediately. No silent degradation. Practice number 2, build quality gates. No data enters production unless it passes validation. Just like code review prevents bad code from merging, quality gates prevent bad data from flowing into critical systems. If data fails, it is quarantined, investigated, and fixed at the source. Practice number 3, monitor models in production. Deployment is not the finish line, it is a starting line. Track prediction accuracy, bias, and business outcome in real time. When performance drops, you need to know why. Is it drift, data quality, feature issues, behavioral changes? Continuous monitoring, keep AI safe and reliable. Practice number 4, enable complete lineage. Every data point should be traceable from source, transformation, a feature, model, decision. When something breaks, and something always will, lineage tells you exactly where, why, and how to fix it. Without lineage, you are debugging blind. Practice number 5, create feedback loops. When a model makes a wrong prediction, a false positive, a false negative, that should trigger a review. Was the data correct? Was the drift involved? Was the feature pipeline appropriate? Feedback loop turns failure into improvement. These practices are not exotic. They are standard in software engineering, but many organizations forget to apply the same discipline to data. Those that do achieve dramatically more reliable, trustworthy AI. Let me address the elephant in the room. This all sounds expensive. Data quality programs require investment. So let us talk about the return on that investment. First, the cost of poor quality, the money you are already losing. Gardner Smith's organization lose an average of 12 million per year due to poor data quality. That is not infrastructure spend, that is pure waste. Failed project, rework, compliance penalties, and lost opportunities. Other studies show that bad data puts 20 to 30% of total revenue at risk through poor decision, customer churn, and operational inefficiency. Now let us flip the equation and look at the gains when organizations implement systemic quality programs. 25% faster time to market for AI initiative, 50% reduction in retraining cycle because models degrade more slowly, 40% improvement in model accuracy simply by improving data quality, 70% fewer compliance incidents because your data consistently meets regulatory standards, and the most valuable benefit, customer trust, reliable, fair, predictable AI, strengthen loyalty and brand reputation. Here is a framing that they resonate with executive. Data quality is not a cost center. It is a strategic force multiplier that amplifies the ROI of every AI investment you make. So the real question is this: would you rather keep losing 12 million per year to bad data or invest 2 to 3 million in quality infrastructure, remove that waste, and improve outcome everywhere? The business case is not even close. Let me close by sharing what I do and how I can help your organization. At DataMind AI, we guide organizations through three critical stages: raw data, AI ready data, decision ready intelligence. We don't hand you a PDF and walk away. We build, we implement, we operationalize. My experience spans 5 areas that matters for production grade AI. The first area is data engineering on modern platform. It is data engineering in Microsoft Fabric, Databricks, and Snowflake. We design and build the pipelines, lakehouses, and architecture that run at enterprise scale. And number two is data quality frameworks, not just defining quality, but enforcing it, automating validation, data contracts, quality gates, observability dashboards, and the full stack. And number three is production AI and the ML pipeline architecture. This isn't research notebooks. It is a scalable, monitored, robust infrastructure that supports real-world AI systems, data governance and observability, ensuring your data is not only good, but accountable, auditable, traceable, and continuously monitored. And number five is Agentic AI and the LLM integration, building the next generation of intelligent systems that can reason, plan, and execute complex workflows. I have led transformation programs across healthcare, finance, and education, and technology deliver real outcomes, reliable AI, and measurable business value. If what I have shared today resonate, if data quality challenges are slowing or blocking your AI ambitions, let us talk. Visit datamindai.com, connect with me on LinkedIn, subscribe to this channel for deep technical dives and practical guidance. Because here's what I believe: AI has enormous potential, but only when it is built on foundation of high quality data. The organization that gets this right will lead their industries. The one that ignores it will become the next cautionary tale. Thank you for time. Now over to you. What data quality challenge are you facing today?